Okay, so I got a few emails, questions about some of the problems here and working them out. So I just wanted to work through one or two here. This is section 1.1, number 52, solving a system of equations. And admittedly, now we know how to do Gaussian elimination and Gauss-Jordan elimination and solve it that way. But for the purposes of this, since it's from section 1.1, I'm actually going to solve it with substitution, or you could try elimination if you wanted, since that's kind of where we were in the book. So I'm assuming that's how all of you are going to solve them. So really quickly, let's see if I can change colors around a bit here. I'll start here. I'll just solve this one for x1. So I get x sub 1 equals 13 minus 4x sub 3. And I'll kind of highlight that so I can keep track of it. Now I'm going to take that and substitute it into this one. And I get 4 times 13 minus 4x sub 3 minus 2x sub 2 plus x sub 3 is equal to 7. This one I'm going to solve for x sub 3. So 13 times 4, that's 52 minus 16x sub 3 minus 2x sub 2 plus x sub 3 equals 7. So if I solve for x sub 3, negative 16x sub 3 plus x sub 3 is negative 15x sub 3 is equal to 7 minus 52, which is negative 45, plus 2x sub 2. Divide the negative 15. X sub 3 is equal to negative 45 divided by negative 15, which is positive 3, minus 2/15 x sub 2, which is not the nicest fraction in the world, but whatever. And again, I'll highlight that. Now take both of them and plug them into the third equation. And if we do that, we'll go right down here. I get 2 times x sub 1, which is 13 minus 4. And now again, I'm going to substitute x sub 3 in right here, because I want the whole bottom one to be in terms of x sub 2. So 2 x sub 1, which is 13 minus 4 x sub 3, and x sub 3 is 3 minus 2/15 x sub 2, minus 2 x sub 2, minus 7 x sub 3, which is again 3 minus 2/15 x sub 2, is equal to negative 19. And now, while it's messy, it's still one equation, all in terms of x sub 2. So let's see. 13 minus 4 times 3 is minus 12. Negative 4 times negative 2/15 is positive 8/15 x sub 2, minus 2x sub 2. Negative 7 times 3 is negative 21. Negative 7 times negative 2/15 x sub 2 is positive 14/15 x sub 2 equals negative 19. Distribute here. 13 minus 12 is 1 times 2, that's 2. Plus 8 times 2 is 16/15 x sub 2. Minus 2x sub 2 minus 21 plus 14/15 x sub 2 equals negative 19. And now if we combine, 16/15 plus 14/15 is 30/15 x sub 2, which is 2x sub 2. And I get 2x sub 2 minus 2x sub 2, which is 0, is equal to, now combine the constants, 2 minus 21 is negative 19. Add the 19 to the other side, and I get 19 minus 19, which is 0. So now, what does that mean? If I get 0 equals 0, that means I have infinitely many solutions. This is always true. The x drops out, so this is no different than when we had systems of equations with 2 variables and 2 unknowns back when you first started solving these. If the variable drops out and you end up getting something that's always true, then you have infinitely many solutions. How we choose to write that out for the purposes of this now, I think the question says first, is it consistent or inconsistent? There's infinitely many solutions, so it's consistent. And now, it's just a matter of how you actually choose to write these out. And in this case, you could probably just use these two right here and set up a parametrization for them. There's different ways to do it, so this one I'll kind of leave open-ended for you. We had a more standard way to do it once we start using the Gauss-Jordan elimination. But here, I actually did several of these in the other video, and you can just come up with your own parametrization based on how you chose to solve it all out. So I don't want to say only do it one way, because it kind of varies based off of how you set up and solve your variables. But yeah, just keep in mind, something like this is completely fine. If we had solved it and gotten 0 equals 2, then it would be inconsistent, no solutions. And now, just so this video isn't just really, really short, I'll do one more example randomly. Let's see. Number 47. X minus y minus z equals 0. Oh, and this is 1.1, number 47. X plus 2y minus z equals 6. X plus 2y minus z equals 6. And 2x minus z equals 5. And again, different ways to go here. Here, I guess, I'll start with the third equation, and I'll solve it for x. So I get, actually, I'll solve it for z. Why not? Add the z, subtract the 5, and I get z equals 2x minus 5. Now, I'll take that, I'll highlight it, this time I'll use black since I already wrote that in blue, and I'm going to stick it in this equation. And I get x minus y minus z, which is 2x minus 5, equals 0. X minus y minus 2x plus 5 equals 0. Here I'll solve this one for x. So x minus 2x is negative x. Add that to the other side, and I get x equals 5 minus y, just because I don't like having a leading negative there. But now I have this for x. Now again, plug both this and this into the third equation, and I get 2 times x, which is 5 minus y. I'm sorry, I'm looking at the wrong one. Plug it into the second equation, x, which is 5 minus y, plus 2y, minus z, which is 2x minus 5, equals 6. But then again, I want to solve this all for y, so replace x with 5 minus y. And I get 2 times 5 minus y minus 5. Now just do all the algebra. Out here, that's 5. 2y minus y is y. Minus 2 times 5 is 10. 10 minus 5 is 5. 2 times negative y is negative 2y equals 6. 5 plus y minus 5 minus 2y is plus 2y equals 6. 5 minus 5 is 0. Y plus 2y is 3y. 3y equals 6, so y equals 2. Now take that, stick it in here. X is equal to 5 minus 2, which is 3. Now take that, stick it in there. Z is equal to 2 times 3, which is 6 minus 5, 1. And I get my solution. And I will point out, again, this is 1.1, which is leading to everything we went to later. Here I just did this with substitution because that's what we're doing now. But we also understand, if I wrote this as a matrix, that would be 1, negative 1, negative 1, 0 with my augmented matrix. 1, 2, negative 1, 6. 2, 0, negative 1, 5. There's my augmented matrix. Now I actually know with this solution, if I got this in reduced row echelon form, let's see, x, 0, 0, x would equal 3, 0, 1, 0, y is equal to 2, z, 0, 0, 1 is equal to 1. And here's my reduced row echelon form with my solutions. X is 3, Y is 2, Z is 1. And if you're looking for more practice, once you've solved this or some of the other ones from 1.1, if you want more practice with your row operations, you know the matrix to start with because we can easily translate this to a matrix. You know what your final matrix should look like once you have your solutions. Do the algebra to make this, or do the row operations, I guess we'll say. Do the row operations to turn that into this. So you can kind of use the problems over and over to practice all the things you're unsure about. Solve the problem one way, and then once you have the solution, use that as a guide to practice all the other stuff you're unfamiliar with. If there are other problems that you have questions about, again, feel free to email me and let me know, and I will work through it. Not a problem at all.